Hi, so today's discussion is about black holes and gravitational waves. Uh, we'll first discuss some relevant information so that discussing about black holes and gravitational waves will make more sense. So we'll discuss some facts about our universe, about our cosmos, which are quite exciting according to me, and then when we'll discuss black holes, we'll understand why it is one of the most cool objects, or it is one of the most interesting phenomenon happening in our cosmos. So basically, the gravitational force, which Sir Isaac Newton was the one who found out about first, like he was one of the greatest scientists of all time, and he was able to connect the falling of objects on Earth and the planets moving around the sun in our solar system, that both these phenomena are happening because of the same force which he called the gravitational force. So basically Albert Einstein, who another one of the great scientists of all time, made some modifications to the gravitational theory which Newton developed. Like Newton was able to give the exact measurements of the gravitational force. The famous formula G m1 m2 upon r square, and then finding the gravity of the earth to be 9.8 meter per second square. Like Newton was brilliant, and he was able to find all the calculations, all the mathematics regarding the gravitational force, whether it was related to the planets or whether it was related to the acceleration of the falling objects on earth. But Newton believed that all this phenomenon happening in our cosmos or in our universe, but he believed that the space in which all these different cosmic objects are there, like these planets, sun, solar system, galaxies, like he believed that the space is basically like a stage, and on that stage all these different actors like sun or the planets are playing their role, are doing different things, and the stage is some inert platform on which all these things are happening. So he never believed that there is some kind of interaction of these objects happening with the space. He believed that it is just a stage on which all these cosmic objects are doing some motion or doing some kind of interactions are happening. Like in his famous book Principia, he wrote that I don't know what is the agent which is causing this force of attraction. He was able to give all this mathematics, all these calculations regarding gravitation, but he also was not sure what is the mechanism which is causing this attraction. This is blue planet sun here, our earth here, sun here, but what is happening in between? What is causing this attraction actually? Right, and another important thing is this electromagnetic, like we have this electromagnetic force, like the force between the two electrons, the repulsion, or if there is an electron and proton, there's an attraction. So that force is like 10 raised to 42 times stronger than gravitational force. Gravitational force is comparatively a very weak force compared to electromagnetic or the strong and the weak nuclear force. Strong nuclear force is the one like which keeps the nucleus together. In nucleus we have all these protons which are similarly charged particles. So the electromagnetic force will try to push them apart. There should be a repulsion because they are similarly charged particles. But the strong nuclear force, which is 100 times more stronger than the electromagnetic force, keep the nucleus together. So all these forces are much stronger than gravity, and the electromagnetic force, there's a repulsion also, there's attraction also, but gravitational force is only attraction. So yeah, there are certain things which remained open, but Newton did a great job. Obviously he was able to connect, as I said, like connect things happening on our blue planet and things happening in the cosmos, right? That the same physical laws are governing the motions here also and the motion in the heavens also. And then Sir Albert Einstein. Albert Einstein came and he did some modifications to the gravitational theory developed by Sir Isaac Newton. So Albert Einstein, who was also one of the greatest scientists of all time, I think we can keep his name together with Sir Isaac Newton. And Albert Einstein also had this curiosity, like what is the mechanism which is causing this force of attraction between different objects on our planet and in the cosmos. Like all our galaxies and everything is formed because of gravitational force. Like the gravitational force, you see the real real strength of that force when you talk about very massive objects, right? Because in the formula G, gravitational constant into m1 into m2 upon r square, right? It's inversely proportional to the distance, but it is directly proportional to the masses of the two objects. So the real strength comes into picture when there are very, very massive objects. And Earth is nothing, like Earth is nothing in the cosmos when it comes to weight or even size. Yes, it is a lovely planet, but yeah, when we look at the universe, it's like a speck of dust in a field of sand, right? It's just a speck of dust. So basically, like these galaxies and all these large objects that we see in the cosmos, all are formed because of the gravitational force. So even the stars, like the stars were formed like when due to gravitation, the hydrogen gas came together. The gravitational force caused the hydrogen gas to come together, and the hydrogen gas then started collapsing against the gravity. And what happened is that the collisions of the atoms increased, the jiggling of the atoms increased, and what happened after a stage of compression, like there was so much heat generated that the fusion started happening, and from hydrogen helium was created. The thermonuclear reaction started happening, and that basically was the start of formation of a star. These thermonuclear reactions which happened, like basically generated a lot of heat, which created an outward pressure, and this outward pressure started balancing the gravitational force. The gravitational force was trying to collapse this cloud of gas, and the thermonuclear reaction was creating a pressure outside, and these forces balanced each other, and that basically created a star. So this balance happened, and the stars were created, and there are some stars which have a life of millions of years, there are stars which have life of billions of years. Like our sun has been existing for 4 to 5 billion years, and it is probably going to exist for another few billion years. As per the mathematics and as per the calculation, it should be there for another few billions of years. And there are some stars which have a life of millions of years and then they die. So how the stars die? Basically, when this fuel runs out, in the star, then obviously the outward pressure which was balancing the gravitational force slowly reduces and goes away, and then the gravitational force collapses the star. Like the stars which are millions of kilometers also, they are collapsed to a few hundreds of kilometers. So the gravitational force basically collapses the star, and that creates extraordinary pressure. There is an explosion, like we have explosion of a nuclear bomb or hydrogen bomb, and that explosion is called a supernova. And after that explosion, this compressed matter keeps on getting compressed until it reaches a point mass. So whatever matter is remaining, like some of the matter is converted into energy in form of this explosion. Like from Einstein famous equation E is equal to mc square, we know like some of the matter, like the energy, the mass can be converted to energy. So some of the mass gets converted to energy, but the remaining mass collapses because of this extraordinary gravitational force. Because it's a very massive object, the stars are very massive objects. Like sun is nothing, like we have stars in the galaxy which are millions and millions of times mass of sun actually. So they collapses into a singularity. Singularity is basically that they collapse into a point mass, like which is kind of a zero volume mass, but the mass is like almost, the density is almost infinite, and it causes infinite curvature in space-time. When I say infinite curvature in space-time, like that's where I would like to come to what Einstein did. Basically, like as I said, like Newton believed that space is basically inert. It is not interacting with the objects. It is just a stage where all these cosmic objects are doing different movements and all that. The cosmic dance is going on. Einstein said that gravity is basically geometry of space-time. Einstein said that because if there is a massive object, that is going to create a curve in the space-time. It's going to create a curve. It is going to create a warp or curve or a dent in space-time. Like if you keep a very massive object on something which is flexible, like on a bed sheet or something which is flexible, obviously it is going to take it down. But similarly, like our sun has taken the space down, it has created this curve, and all these planets which are there in the influence of this curve are orbiting around the sun. because of the geometry of space-time actually. So Einstein said it's not any force which is acting, it is like the curve which is created by these massive objects which result in things falling. So when you throw an object, it falls down, it comes down because the curvature of space-time around the Earth. And the planets are moving around the Sun because the curvature of space-time created by the Sun. I am using the term space-time. So space, we understand, we are talking about these heavens in the sky that we see. And obviously we don't see the curvature happening, we don't see the air also, but we don't see the curvature happening. But as per Einstein's general theory of relativity, any massive object or any object is going to create some curve. Like even we are going to create a curve, but it's not going to be perceptible because that's going to be very, 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 very small. But massive objects like Sun, very, very massive objects like the other stars are going to create big curve or big dents in the space-time, and that is going to cause the motion of these planets around that, or motion of other cosmic objects around that massive object. And so when I'm using the term space-time, like Einstein combined this three-dimensional space x, y, z and the time actually, and he called it space-time. So as per Einstein's general theory of relativity, the time also gets warped. What is the meaning of time getting warped? Or what is the meaning of time getting curved? How can the time get curved? We can understand the space getting curved under the pressure of a massive object, but what is warping of time? What is curvature of time? Like time, we understand like there are different time zones. Obviously the time in India is going to be different than time in America, but that is not a different ticking of time. It's just a different time zone, right? When we say curvature of time, what it means is that a second on Earth is different than a second near Sun, is different than a second near very massive object, is different than a second near the black hole. So I'll come to black hole, but the second, the ticking of a second, the ticking of the speed of time changes. The speed of time changes according to the gravitational pull. If the gravitational pull is stronger, it is going to slow down the time. If the gravitational pull is weaker, it is going to, the time is going to run faster. Like the time is going to run faster on Earth than compared to if you are closer to Sun. If you are compared to black hole, the time is going to slow down drastically because it's a very, 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 very massive object. As I said, like the mass, millions of times mass of the Sun is crunched, is compressed, is collapsed into a point mass, right, which is of infinite density. Like where does that mass go away? It's still a mystery. Like we don't know like how it gets converted into a point mass, and it is called singularity. And basically a black hole is, as I talked about, that it's a collapse of a star, and this point singularity is there at the center of it, and then there is an imaginary boundary around it which is called event horizon. So event horizon is basically the boundary of the black hole, and in between the singularity and this boundary, this imaginary boundary called event horizon, in between there is only empty space-time actually. There is no matter, all the matter is collapsed into a point mass. We don't know where all that mass has gone away. It's still a big mystery actually. How it is collapsed into a point mass. When I say point mass, it is not like we can see a point on the paper. It is just an assumption that it is collapsed into a point mass called singularity of infinite density. It is smaller than anything that we know, smaller than an atom, smaller than a proton, smaller than an electron. We don't know actually, like where all that mass has gone away. Is it creating another universe on the other side with that mass? We don't know what is happening, right? So this event horizon, the imaginary boundary which I am talking about, anything which crosses this event horizon and comes towards black hole cannot escape from the black hole. Anything is going to be eaten away. Anything crosses event horizon, it's going to be eaten away. Even the fastest thing in the universe, light. Light also, if it enters the black hole, it is going to be eaten away. That's why these are black holes, because they don't reflect light, they just eat away the light, like they eat away all other matter which is coming near it. Anything which crosses the event horizon is going to be eaten away. Even light is going to be eaten away. Light is not going to be coming out of black hole, it is going to be eaten away. That's why those holes are black. In the dark sky, they are black holes, that's why we cannot see them. We are able to basically understand that the black hole exists because of their gravitational effect. Because any matter which is near the black hole is going to eat it away, and while it is pulling that away at high velocity, it creates a lot of friction, it creates a lot of heat, and that creates a lot of shine around the black hole. So that is called the accretion disk actually. So when it is eating matter, when it is hungry, when it is eating all the matter around it, then it is going to light up the area surrounding the black hole, and that tells us, okay, something like black hole exists. Earlier there used to be a lot of question, even Einstein himself, his general theory of relativity predicts that black holes exist, but he himself was not very sure of it. He once wrote a paper that they exist, then he wrote it, they don't exist, so that kept on going, and finally there were other scientists also pitched in, and then it came basically into forefront, yes, those kind of objects can exist. Though it came out of Einstein equations, there were other scientists who basically contributed to it. Also our great scientists like Indian scientist Subramaniam Chandrasekhar, like he played a great role. In 1983 he got a Nobel Prize also for the same actually. Basically he did a lot of research on how the stars collapses and what kind of mass stars are going to get converted into black hole and all that. So he also played a significant role towards this physical processes happening in the stars. So one important interesting thing, now we understand what are black holes. So I talked about gravitational waves at the start of a discussion. So when there are major movement or motions happening in the cosmos, as I said, Newton said that space is like a stage, but Einstein said that space is not like a stage, it interacts with the matter. If you have a massive object, it's going to curve the matter, it is going to curve the space, and according to that curve the other matter is going to move around that massive object, right? The motion of those other object is going to depend upon the curvature which that massive object has created. So when some accelerated motion happens in the cosmos due to some massive object, or when there is some asymmetric motion which is happening, obviously due to very massive object, then gravitational waves are created in the space-time. Gravitational waves are created in the space-time. These are ripples like in a pond. If we move the water actually, then we'll see the waves, right? So similar kind of ripples or waves are seen, which are called gravitational waves. So these are the waves which are created like when two black holes collide. I'm just taking one example. It can be created due to supernova explosion also, like the explosion of a star also. But when two massive black holes collide, obviously the intensity, the energy of it is going to be much higher. And the interesting thing is that this is something which was predicted actually by Einstein and other scientists, but it was not discovered. Like 1915, 1916, Einstein was talking about it when he wrote General Theory of Relativity, and it was in 2015 September that basically we were able to detect gravitational waves on our planet. So Louisiana and state of Washington, there are gravitational laboratories, observatories, which is called LIGO. So there these gravitational waves were detected in September 2015, and in February 2016 they announced it. So basically we were able to detect the gravitational waves, which was a big discovery, because so far whatever information we are getting from the universe is from the light. The light is coming and that is bringing information about the stars and about cosmic objects. That was the only postman or only mode of information conveying for us actually from the universe. That is how we are learning about the luminosity of stars, the distance of different objects, different cosmic objects in the universe. But this is another thing which is going to give us information about the universe, the gravitational waves. So it is not light, it is basically the rippling of space-time actually. Because of the collisions of black hole, what is predicted is there's a collision of two black holes 1.3 billion years back, and billion light years back. Basically the light has taken 1.3 billion years to reach us and has conveyed to us that information that 1.3 billion light years back there was a collision of two black holes, and those waves were transmitted into the entire universe, and some waves came to our blue planet and we detected it at Louisiana and state of Washington. And basically this is going to start a new era, because we have another way of finding out information about the universe. And this is also confirmed the existence of black hole, on which there were a lot of questions earlier, but based on the waves which have come, it has indicated that it has happened due to the collision of two black holes. There were two black holes, they were falling towards each other due to gravity. They were spinning around half the speed of light or half to like 3/4 the speed of light, and then they merge into each other. So when they were spinning, there was a lot of accelerated motion happening, and that was disturbing the space-time. And when the merger happened, there's a major disturbance, and then it became quiet. It became a larger black hole. Like there were two black holes. It is predicted that two of the black holes were like around 30 times mass of Earth each, and when they combined, some of the mass was converted into this energy, and the rest of the mass combined to become one single black hole, bigger black hole. So this energy which was transmitted came in form of space-time ripples, and it was spread into entire universe. And our universe is quite huge actually. Right? The universe is expected to be like the observable universe, which we are able to observe with the light coming to us. Right? Is expected to be size of 90 to 100 billion light years. So when we say light years, basically 90 to 100 billion years is a different thing. 90 to 100 billion light years. How much a light can travel in a year? Light travels 3 lakh kilometers per second. So our Earth circumference is like 40,000 kilometers, and the light is running at speed of 3 lakh kilometers per second. So in 1 second tick, the light can make 7.5 revolutions around the Earth actually. So this is how fast the light runs, and that is the fastest interaction of matter can have actually in our universe. The light is the fastest thing in our universe. In special theory of relativity, Albert Einstein also says that nothing can cross the speed of light. That is the maximum actually. And one thing which I talked about, like near the black hole, the gravity is tremendous. Tremendous means the light, as I said, like once it crosses the event horizon, even the light cannot escape. Right? So if you are near the black hole, the gravitational pull is tremendously strong, and it slows down the time. The Einstein general theory of relativity indicates that as the gravitational pull increases, as the gravity increases, it is going to slow down the time. So near the black hole, because it is like infinite density point mass, infinite curvature of space-time, the curvature I talked about, because if it's a infinity density point mass, obviously it is going to create infinite curvature of space-time. So the time almost stops. If you cross that, the time stops for you, and near the event horizon the time becomes tremendously slow. It depends upon the kind of black hole. It's a small black hole, large black hole, but it becomes tremendously slow. Like a 1 second near the black hole, maybe years and years and years passing on the Earth. And certain black holes, like very close to the event horizon of a black hole, maybe a civilizations may pass on our blue planet, right? So this is basically it is one of the most interesting objects. And now there's a project called LISA. Like they are putting probes in space to see the shadow of the black hole. See, black hole is dark, so you cannot see the black hole directly.